Hey there folks, Mr. G again, back with another educational video. This week we're going to be talking about some more linear word problems. These ones have to do with coins and the age of people. Now before we dive into these, I wanted to go over a little bit about why we're doing these types of problems. I'm sure you realized last week when we were solving ones related to numbers and shapes that these types of problems aren't really going to come up in the, quote, real world. And these ones are the same, even though they're maybe more related to things in the real world. The reason why we're doing these types of problems is because we're trying to develop a skill. And that skill is taking language and turning that language into mathematics. Now this is an extremely valuable skill. It's a skill that you're going to use all the time in your other courses, in math courses, and out in the real world. So while these problems aren't necessarily the kind of problems you would solve in the real world, this skill of taking language and turning it into mathematics, and then sometimes relating that mathematics back to language again. So how does the mathematics inform the problem that you were solving and the answer to that problem? That's a really valuable skill, and that's what we're going to be developing by doing these word problems. So our first problem here, this is going to be related to age. Harry is 2 and his father is 35. In how many years will Harry be 1/4 of his father's age? Just like before, we're going to want to make sure to highlight the important information. So the important information are the ages of the two people here, and the fact that we want to know when Harry is going to be 1/4 of his father's age. So that's how many years. This is what we're going to be trying to solve for, and that's what I'm going to call our variable in this case. So we're going to call x the number of years. So if Harry starts off at 2 years old, and the number of years is x, then the number of years that Harry will be whenever we reach 1/4 of his father's age will be 2 plus x, some number of years. We don't know how many yet. For his father, he starts off at 35 years old, and they're going to age at the same time, right? So when Harry gets 1 year older, his father also gets 1 year older. So whenever it is, however many years it's going to be, they're both going to have x added to that number. So if x were to be equal to 3, so 3 years later, that tells us that Harry would be 5 and his father would be 38. Now obviously 1/4 of 38 is not equal to 5, so that's not going to be our answer, x equals 3, but this is where these equations come from. So once we have this, the fact that Harry's age will be 2 plus x and his father's will be 35 plus x, we can use this last line here to set up an equation that we will solve. That equation is that Harry wants to be 1/4 of his father's age. Now just like before when we were dealing with fractions, 1/4 of his father's age is not just 1/4 of 35, it's 1/4 of 35 and this plus x. So we need to put brackets around this. Once we have this equation, we know how to solve it. First thing we want to do is distribute in this 1/4. Now we see we've got some fractions we need to get rid of. Luckily they both have the same denominator of 4, so we can multiply through by 4. And you should end up with something that looks like this down here. Again, we're going to take all of our x's, I'm going to move them to the left, and take all our numbers, move them to the right by doing the following. I'm going to subtract x from both sides to get rid of x on the right, and subtract 8 from both sides to get rid of the 8 on the left. We'll end up with 3x equals 27, divide both sides by 3, and we'll get that x equals 9. Now 9 in this case is our answer, because we're asked for how many years it will be, and we define that to be x. So in this case, our answer is just 9, or you could say 9 years. Here's our next question, again an age question, though this one's a little bit different. So Margaret is 3 times Barbara's age. In 8 years, the sum of their ages will be 100. How old is each person now? Again, take out your highlighter, let's highlight the important information. So the fact that she is 3 times Barbara's age is important. In 8 years, we're adding up their ages, we get 100. How old is each person right now? That tells us where we're going to actually have 2 answers in this case, unlike our first question where we only had 1 answer, the number of years. Next thing I want to do is set up some variables. Since Margaret is 3 times Barbara's age, I'm going to define Barbara's age as x, which would make Margaret's age 3x. Note that this is how old they are right now. We're told that they're 3 times Barbara's age right now, but we're also considering how old they're going to be in 8 years. So in 8 years, Barbara's age is not x, it's going to be x plus 8. And Margaret, similarly, is going to be 3x plus 8. And the information that we're told is that the sum of their ages in 8 years is equal to 100. So our equation is going to be adding up their age in 8 years and setting that equal to 100. And now we've got our equation. We've got some like terms on the left-hand side here, so let's gather those up and simplify. Going to move all my numbers to the right side by subtracting 16, and then finally dividing by 4 to get my answer for x. So our answer for x is going to be 21, but make sure that this isn't your only answer. Remember, how old is each person? So we actually have two answers in this case. Our first answer is going to be 21, so Barb is going to be 21, but Margaret is going to be 3 times 21, which gives us her age of 63. Now for both of these questions, after you're done, you can check them. So the piece of information that we're checking is that in 8 years, the sum of their ages is 100. So 8 years later, we get that Barbara is going to be 29, and we'll get Margaret is equal to 71 years old. If we add those two ages together, we get that they're equal to 100. So we know that we got this right. We can do a similar check for our previous question. We're told that in 9 years, Harry should be 1/4 of his father's age. So let's check Harry's age. That would be 11, 2 plus 9. And his father would be 35 plus 9, which is 44. And if you notice, if we take 44 and multiply it by 1/4 or divide by 4, we get 11. So we know that this one's correct as well. That's the end of the first video. You're welcome to try some of the problems related to age that I've assigned, or stick around for the second video where I'll be going over the coin problems. See you then.